Hey, hello, and welcome to the show. It's me, John Park, and it's time for the St. Patrick's Edition 2022 of John Park's Workshop. This is the greenest shirt I had. I apologize. My sneakers are a lot greener. But the shirt, not so much. Welcome. Are you celebrating St. Patrick's Day today? I don't know why I'm making such a big deal out of this. Now it's weird. Now it feels weird. Let's see, what do we got going on for today? I have, let's say, to start things off, jobs.adafruit.com. You might want to head on over there if you're looking for work or if you're looking to hire someone. This is, in fact, what it looks like when you head there. And there's some projects we've mentioned before here. Nothing new since the last week or so in the help wanted section there. But you can see there's a bunch of projects that are contract positions. There's also some remote work and full-time work, part-time. So head on over there. It's free to use. It's free to set up. All you need is an email address and account with Adafruit. All of the listings are vetted, and so you can trust them. If not, bring it up with PT and Lamore. You can also head over to this available for hire section. I'm not logged in on this browser right now, so I won't see anything. But once you're logged in, you can check out people's resumes and try to find someone and do some work for you. How about that? If you are joining us over on Twitch or one of the other sites where I'm not looking at the chat, I am looking over on YouTube. Hey, Anthony and Jose Maria, nice to see you all. And this is our Discord here, so if you want to jump into the Discord chat, you can go to adafru.it/discord and then head over to the live broadcast chat channel, and that's where the conversation's happening. I am curious, actually, if anyone in the chat can let me know if Twitch is up. Oh, it looks like, yeah, it looks like it is. Restream wasn't giving me any feedback, and I wasn't sure if we were broadcasting there right now, but it looks like we are. Good. Let's see, next thing, I have to do a little maintenance here. I have a show on Tuesdays that's called JP's Product Pick of the Week, and I need to add a little update here so we can show the video from this past week. I do a little 1-minute recap I like to show during this show. The show on Tuesdays is at this time, so 4 o'clock Eastern Time, 1 o'clock Pacific. It is usually around 15-20 minutes. I go over a new product pick or a highlight from our archives, and we have a big discount, usually 50% discount on the product during the show, just during the live stream. So if you can tune in live, you can just log in and grab an item, usually at 50% off. There's no coupon code or anything, so just throw it in your cart. You can usually get a limit of 10, so you can't hoard stuff too much, but 10 of something isn't bad. And just give me a second here because I need to load up a piece of media. And I wasn't able to grab it before the show. Let's see. Here it is. Here's the 1-minute recap of this week's product pick. It is the OLED Featherwing 128x64 display. You can use that STEMMA QT port to add another peripheral. So this is Bongo Cat. And if I hold these are going to play a little sweep on the Game Boy, original Game Boy audio hardware. The extra bonus here is that you can see I've plugged into the STEMMA QT port a little accelerometer, and as I tilt that accelerometer, it's a variable that changes the rate of that sweep. It's a pretty short sweep if I'm at 1, gets a little longer, and even longer. On the side of the OLED, same pins as my Feather, NeoKey Feather there. OLED Featherwing, it's 128x64 I2C display with STEMMA QT port. That was going to try to loop on me, but I caught it, just barely looped. So that was product pick, a cool one, really, really nice one, and that's a big update from the previous one. I think we still sell both versions, but there was a 128x32, so half the height that we used to carry. OLED Featherwing, I'll show the options there. If you check out Adafruit and just go OLED Fev in the search, you'll see here's the new one, 128x64, and that was the one that was half off yesterday. And then we also have the 128x32 if for some reason you need a tinier screen, but they're actually the same price. So that was product pick of the week. Tune in next Tuesday for a new product pick. And I won't give away what it is. I almost said it. Okay, so let's see. Next up, why don't we jump into our CircuitPython Parsec. I'll get all set up for that. CircuitPython Parsec. Okay, so for this week's CircuitPython Parsec, I wanted to show you a little trick you can do with swapping out colors in an image palette using Display I/O. So this is part of our continuing series of Display I/O tips and tricks. This was based on a transparency-based trick that Toddbot had put up on his tips and tricks page. And by the way, I'm going to be working on a collaborative guide with Todd where we will put a bunch of his tips and tricks into a Learn guide. So it'll include examples and maybe some of these videos as well. So for this one, what I have is an image. This is another one of these really terrific voxel pixel art images. And give me a moment because I want to give credit. I've forgotten the name of the artist on this. And if you want to look it up, it is Meral Ezgi, M-E-R-A-L, last name Ezgi, E-Z-G-I. Look those up, Meral Ezgi, a bunch of voxel-based art that looks like pixel art. Here we have an 808 drum machine image. It's very cool looking. Right now what I'm doing is I'm just using the Adafruit image load to load this BMP image up on screen. And for now, I'm just leaving it up there. But the trick, the thing I wanted to show you here, I'm going to uncomment my code and resave it to the board. And now what you're going to see is it's going to go through and one by one replace each color in the palette with green. You can pick any color you want. You can do more sophisticated things. In Todd's original example, he was using transparency so he could reveal something behind. But here what you'll see is just every time it loops through, it's going to display the original image for a second, and then it's going to start just making its way through the palette, every palette in the image, and switch the palette value for green. If I change this out, we can do something like, let's say, red. It's not quite as visible, actually, because this starts out as an orange image. But you can see there, one by one, each of those colors changing. And this is a really neat trick. It's something that has its roots in video game art, typically, in real-time video game art, using palettes to swap how things look so that you don't have as many big, heavy assets in your scene was a common trick. And so this is a way that you can take the image after loading it. If you take a look at the code here, we're doing an image load, we're setting up some Display I/O stuff, and then this function here, image and palette, are cast into this Adafruit image load, and then the name of your BMP image. Sets up the bitmap as a tile grid image using a pixel shader based on the palette. And then in the main loop, what I'm doing is grabbing that palette based on whichever image, you can have multiple images in here, the pixel shader on the image, in this case the 808 BMP. And then one by one, I go through however many colors are in the palette. You could have a one color palette, you could have 128 colors, 256, however many are in there. And I'm saying take each one, starting on the first one, and replace it with whatever color I've picked. So if we go in here and change this to blue, let's say, hit enter. Now, whoops, did I? Oh, that's good, all right. Let me hit save there. So now what you'll see is it just goes through one at a time, changes it, takes a little, a moment there. We can delay how long it sweeps through those, otherwise it goes too fast to see. And then it holds that image for a second and repeats it. And so that is how you can replace the colors in an image with a specific color using Display I/O's palette shaders. And that is your CircuitPython Parsec. CircuitPython Parsec. All right, so I should grab some other art to show those things with, because it's really interesting depending on the style of image. If you have flat artwork, if you have some sort of dithered, shaded stuff, it really can have a cool effect there. Oh, and we have a Foamy Guy in the chat. I saw Foamy Guy starting to talk in our Discord. Maybe you have ideas about palette as well. And let me know if you have some specific tricks you'd like to show. If you want to share some, I can do future CircuitPython Parsecs on other palette tricks, other display I/O tricks, or other general CircuitPython tricks. Let's see. So I'm checking out over in the YouTube chat. Jose Maria Tierina says, hello, it's the first time I'm watching your broadcast. Could you give a brief explanation of what you're going to build, assemble, or show? Well, yeah, actually, that's a really good lead-in to what's happening next. So the main project that I wanted to show that I'm getting started on, that I'll be working on a learn guide for, so you can watch this, see sort of the beginning steps of how I'm putting this together. And then I'll be writing a learn guide that'll give you the specifics on it. If I jump to my bench cam, I have this, let me turn on one light that I forgot to turn on here so you can see a little better. I'm very excited because I just got this new gaming handheld delivered the other day. This is the, wiggle that on and off there. This is the Steam Deck, and what I'm going to do is actually I'm going to unplug this stuff here, and I'll go and just restart that game there. Let me see if I can jump to that view as well. Okay, so let's exit the game. Confirm. So Steam Deck here, if you're not familiar with it, this is a gaming console that is essentially a Linux-based machine that can play with a really nice emulation layer all of, or many of, the games in the Steam library, the Valve's game service. It runs an emulation layer called Proton, I believe, or yeah, I think that's right. I'll have to look that up. And it uses this nice Steam UI to make it present more like a game machine, so you can go and look in your library of games, download games onto the device, and then play them. It can work essentially like a gaming PC in that it has a USB-C port that can do everything from mouse, keyboard to video over that port. So you can use a dock. There's a forthcoming dock that'll allow you to use this just as a PC, but then grab it on the go if you want. I'm using, for the stuff I've just started playing with, a pretty typical USB dongle that has a USB-A port for peripherals, an HDMI out, and a power USB-C that'll keep it charged. In its default sort of intended use, you can just grab the thing and go. It's got pretty typical modern gaming controls on it, a couple of analog sticks, a D-pad, button cluster, some little trackpad kind of guys here, and some buttons on the back. And what I wanted to do was see how we can make our own controllers for it. And so the idea behind this is to use a CircuitPython based board, in this case the Circuit Playground Express, which we can plug in over USB and treat this as a gamepad. So we're used to taking these kinds of devices and sending keyboard commands to things. Hold on one second, I just realized there's another light that's out. I think that one's based on a remote. Sorry, there was a weird incident earlier today that kept me out of the workshop. There was a chemical spill not far away, and so we had kind of shut the doors and stayed inside, so I'm a little delayed. I think everything's going to be okay though, so let me see. There we go, that's on now. Much better. There we go, we have light. So you can connect this as a keyboard. However, there are things in the user interface once you start a game that don't actually work all that well with the keyboard unless you go in and mess with a bunch of settings. So, for example, I don't think there's a keyboard command, not one that I found on a typical HID keyboard, that will hit start for you. So on a gamepad, typically any button or the A button will start and get you into the game. And then you can navigate usually with arrow keys, but then something like this to hit start, there was no button on the keyboard that would work. So rather than use HID keyboard, I decided to explore HID gamepad. And this is sometimes called, I think, HID joystick. But in CircuitPython, we have methods of sending gamepad HID descriptors and commands. And so these are sort of a different flavor than mouse and keyboard based on the same kinds of ideas. And this allows you to send these types of commands over USB. So typical, very dusty, haven't used this in a while, this is an Xbox 360 controller. And these will have the button cluster of A, B, X, Y. They'll have the start and the back button, which are some of the ones I needed in this case. A home button, which on an Xbox is this X. On the Steam, it's this Steam, which kind of pops you up a layer, similar to a Windows button, that type of thing. They usually have a D-pad of some kind, a couple of analog joysticks, and then sometimes some click extra buttons built into the joysticks, shoulder buttons, analog in some case shoulder buttons. I think these are analog triggers on some of the game pads that I have. I can't remember if it is on this one. And sometimes other buttons on the back. So that's a fairly typical modern game controller. But even with really simple examples of a game controller, which would be more like, I have one over there, but more like a SNES controller, let's say D-pad, 4 buttons, a couple shoulder buttons maybe, a couple of start and select buttons. Those are all gamepad, and so I want to be able to emulate those with my Circuit Playground Express. And one of the reasons I want to be able to do that is I would like to be able to control, for reasons of it just being fun and funny, I want to control this game Cuphead using some cups and straws. So using capacitive touch, we have 7 capacitive touch pads available on the Circuit Playground Express that we can use to connect to things that we can then use our own capacitance as a capacitive antenna to determine when we've pressed a button or not. So that's the idea. Let me pop open my Discord on my phone here just so I can see if anyone's got thoughts or comments, or if my audio goes out. That's always the big fear. But I hope that long answer satisfies your question there, who had asked that in the chat. Yeah, Adam Cadillac says, jealous, Q3 for mine. I don't know how I got so lucky. I mean, I think a lot of us ordered these on the day that they were released, and then somehow mine came pretty quickly. So I'm excited about that. And I've been playing Firewalk on it, which I'd never played. Loving that. I'm about to start Elden Ring, so that's going to be my big hobby, is Elden Ring on this little Steam Deck. Okay, so it looks like we're good. Looks like audio is working. I'll set the phone over there. So let's give this a go. What I'm going to do is plug in my little dongle there. Interestingly, I found the Circuit Playground Express with a USB-C to USB micro B cable works directly plugged in. Some normal mechanical keyboards that I was plugging in, not handmade ones, like commercially made ones, were only working through this hub for some reason, and I'm not quite sure why. But interestingly, this Circuit Playground Express worked straight into the device. The only reason I'm using this hub right now is so that I can keep it charging as well. I could also do the HDMI output if there was a reason to. So let's see. Let's reset the Circuit Playground Express. Some of those things came unplugged, but let's see. Will it? I don't know if I have anything hooked up right now that'll tell it to start. So let's. Oh, okay, that one is. So this, I just touched this straw. This is essentially acting as my A key. So again, this was the cool thing about gamepad versus keyboard. Gamepad A is pretty powerful, and the receiving device is usually set up to know, since a game controller only has a limited number of buttons, that A button is often what people are hitting when they want to just progress. And keyboard A wasn't doing that, same thing. So again, you can see here I'm able to touch this metal straw that's connected up to one of the capacitive pads on my Circuit Playground Express. Again, start, pick a player, pick this guy. And this is highly incomplete right now, so actually I may, I think I'll have to use 2-player to even start, because I don't have D-pad stuff working yet, just up and down. So I'm having my second player use these controls at the moment, just for this demo. I'll work that out. But just to demonstrate it, you can see A is jump, and that's going to work just by touching this straw. The start button, or that's B button actually, I think. Yeah, the B button in this control setup is what pops us back out. So you can see that player. Is he using B? Oh no, maybe it is the start. Whatever button that is. We'll look at it in my code in a second. And then if I want to shoot, I've got, I just have this alligator clip right now going to analog 4, touch input 4 on the CircuitPython Express. Now, this may require recalibration. You can see I've just connected that clip to a metal espresso steaming mug, and I'll reset the board. And when the CircuitPython Express restarts, it should do a calibration. It has, I believe it has some auto calibration code built in. And now it doesn't think that that button's being pressed permanently. So I can shoot just by touching it there. I can jump and shoot. And we can go back. Other controls on here, let's see. We can, okay, that's dash. And I don't want to dash too much because I'm going to dash forward and die. If I touch the A6, that's down, and A7, that's up, versus jump up. And let's put that back on the shoot there, and we should be able to point upward and shoot, or point downward and shoot. It's kind of a crouch. Okay, so that's the basic demo. It's going to be terrible to play the game with this right now, and to be honest, it'll always be terrible because real controls are way better than this, but I think it's fun and interesting to try it out. Could be useful for some things. For, one example, of course, is for assistive technology. For people who aren't able to use the default types of controllers, you can set up alternate controls, even if some are on a controller with one hand and others are on a foot or body part, mechanical stuff, capacitive touch for people who have limited strength in their fingers, for example. Using touchpad things can be really nice. So there are some practical reasons for this. But what I thought we'd do now is jump out, hit any cup to continue. That's right. Boop, boop. I love that. Thanks, Foamy Guys. A great idea for Cuphead controllers. I was showing Cuphead on this to Limor yesterday, and I said I wanted to do something with CircuitPython in this, and she said, how about make a alternate controller where you're touching cups? So I give credit to Limor. It's a fun idea. So what I'll do is unplug this controller here, and let's bring it over to my workstation, and we'll take a look at the code that I have running on here now. And let's get this will be a good view for this, and I'm going to plug this one in case we want to try changing out, excuse me, the code on it. And let's open up that code on the CircuitPython drive. Now that's not it. Oh, it's this problem again where I have cached. I don't think Adam used to do this, but it's now started to cache the thing until I close it out. So let's actually also open up the supporting files that are necessary. So this is all really new to me. I had never done the gamepad HID stuff before. Let me show you the guide and example code that Dan Halbert and others have created that make a lot of this possible. Yeah, sorry, someone asked over in the YouTube chat, the console, what's it called? It's called the Steam Deck. Not to be confused with Stream Deck. That's another thing for changing camera buttons, and your Google searches will often show you both. Let's jump over to the Learn Guides real quick, and HID gamepad, I think. Okay, so I'll bring up, and here you can see, let me zoom out, this is big. This guide called Customizing USB Devices in CircuitPython is really helpful because it has info about setting up your controller type to show up as different USB descriptors to a device. I believe what I found with this is that I needed to have it only show up as a gamepad, otherwise it can confuse the console. So typically when we set up USB HID on one of these CircuitPython devices, they will show up as a series of devices. If you look in your device manager, you'll see things like the USB HID keyboard, USB HID mouse, USB MIDI device, and then also gamepad. It's also a USB storage device and maybe some others. So this guide, mass storage, this guide talks about that and talks about how you can hide devices. So I want it to only show up as some things. And that's done using this boot.py file. This goes into some of the specifics of your setup for having it show up as different things on boot and how to configure it for the different uses. So the one I'm using, I think, is in here under custom HID devices. So gamepad is a little out there. It's not as standardized as a keyboard. This tends to be, it can really vary depending on the type of gamepad you want to emulate. So you'll have a descriptor that matches something like a PlayStation 4 controller or an Xbox 360 controller or whatever you have. So this example that I'm using was based on one that Dan posted that uses this boot.py file. And we also use if you look back at my code here, an HID descriptor, I think is the right, might be the right term for this. Is also game device, gamepad device, and I'll have to remember now. Thankfully, I'll solidify all this thinking as I work on this and put together a guide on it. But there are, if we look in the main code here, we're setting up a gamepad USB HID device, and we're importing this HID gamepad here. So this whole file gets imported to, I think, to essentially say, here's the types of usages, the usage page and usage were the words I was looking for, as well as the device descriptor. And based on that, we're sending bytes that are kind of expected by the device on the other end that fall into button maps, analog values for joysticks, and other things. So what I found, some of these are standard-ish, some of these were just through trial and error. I set up this control map here of either button types or joystick types, and I'll talk in a second about why I did that. But this first group here, these are 5. These are 5. My first 5 touchpads send a gamepad button press and a release of these values. So a 1 sends A, gamepad A. And let me grab that controller there. So you kind of have a physical name. So it's pretty typical that there's something called button A. And what that does in the game will vary. And so as I was notating this in Cuphead, that was jump. So I saw jump happen. I knew based on button mapping that was A. The 8 locks the character in place so that they can stand and shoot without running. The 12 is and that's the right button here. So the gamepad descriptor, I think, allows for 16 buttons is kind of the first chunk of options in there. So I don't know if you can even go past 16. You probably can with your descriptor being customized. Then let's see, the start button here, which is used for starting the game from the beginning, is what I'm using to pause the game. The shoot is X and the dash is Y, and those are 4 and 5. Now, there's a way to use what's called D-pad or hat, and that's your digital pad that's really 4 buttons under there, but that is not in the USB descriptor that Dan set up for that example, and he and I may work on getting that emulated as well. But in actually Dan Halbert's great idea as well. Okay, the example file does have a provision for the analog joystick, actually one or two of them, and so that's a set of two potentiometers that send I'm not sure what they might be 0 to 63,000-ish, but what they want to send is a 0 in the middle, a negative 127 to the left, and a positive 127 to the right for X, and likewise for up and down. And he said, well, for now, what you could do is have some of your touch inputs or physical buttons just send a full 127 or negative 127 or 0, and that'll be the same as the D-pad, which is a binary digital thing. You could use CapSense maybe to sort of emulate analog stuff, but it would be kind of annoying. So in my case, this is the kind of game I don't want to have analog. I don't want to play it with the D-pad. So what I've done is in this little sort of dictionary I've set up, if the 1, 2, 3, 4, 5, 6, 7th one is pressed, 6th and 7th ones are pressed, the first element here is a 1, and that says, okay, we're no longer doing just the button press release, we're now going to do joystick, and we're going to define those as 0 on X, 127 on Y, or negative 127. So that was my down and up, or up and down. And then this would be for side to side, but I don't have enough touchpads, like I said, so I need to reconfigure things and decide how I'm moving and which things I need on there and which I don't. I also have two physical buttons and a slide switch on the Circuit Playground Express, so it may be possible to add some stuff that isn't really used during gameplay, but just for navigating the menu system. This I'm not using right now. That was just for as I started working on this. You can see here I was originally trying this with the HID key codes, but those didn't work out. Then I'm setting up my touch pins, so there's 1 through 6 and TX. The threshold adjust, this is for CapSense, and like I said, I believe it does calibration on start, so I'll dive into that a little more with the different controls that I'm trying to touch as I build this out. And then here's the key stuff for gamepad. In my main loop, what I do is I'm only checking those 7 touch pads right now, so I loop through all of those for I in the range of the length touches. Touch is the current iterative number, so 0 through 6. We do an update, we check has that one been touched. If it rose, that is as if we've pressed it, just because of the pull up, pull down. So if we've pressed one of those, then here is how I'm checking to see, is this one of the buttons or is this one of the joysticks? I say in this control map sort of dictionary up here, is the first element a 0 or a 1? If it's a 0, it's a button, so that's this check here. If the current element has a 0 in that position, then we've pressed a button. And so I grab whatever that control map is, the item 1. And that item 1 is going to be whichever button, button 1, button 8, button 15, whichever it is. When I have a 1 in that first slot, that means we're doing the joystick thing. And then I'm sending this command, gamepad.move joysticks. Now this one is expecting both X and Y. Since it's a digital pad and I'm being simplistic about it and not doing diagonals, then I'm sending either a 0 and a value or a value and a 0, but I'm never mixing them, and I could probably make the code a little more forgiving of sort of diagonal moves, which you'd want ultimately in the game. And then we do the release when we release one of the buttons, gamepad.release buttons for whichever one we had touched. And for the release of the joystick buttons, I'm just sending 0, 0, which means you're not moving. It's always relative. And so that's the sort of rough working version of this that I just got working this morning, because I really thought it was going to be so much more straightforward by using keyboard, but because, like I said, because of some reasons that didn't work out, I got to dive into this, and so I'm really excited about, because this is a really useful specific type of USB HID, which is gamepad. And so let me know in the comments if people have done any stuff with gamepad, if you have any suggestions or places to check out more info on that, especially if you've done it inside of CircuitPython. That would be great to see what you've done with it. You can find the USB HID descriptors online if you look for them for various controllers, and that's also a step towards emulating the specific behavior of a particular controller. Let's see. Other questions that we have in the chats. Jump back out here for a second. Someone asked, "Is it an expensive console?" It's about $400 US for this entry-level one. They have a couple of different levels of them. That the next level up, I think, doubles the storage space. It has a little solid-state storage in it. This one has 64 gigs, but it also has a SD card, so you can play the games effectively off of the SD card. People have been reporting good success from that. And then they have a third tier one. The most expensive one has double that. I think it's 512 gigs, and it also has, I think, a nicer screen. I'm not sure if it's just the glass or if it's the OLED itself. But yeah, for me, I don't have a gaming PC, and so spending $400 for what can act as a pretty decent gaming machine if you want to plug keyboard, mouse, and monitor into it over HDMI, it's not bad, and then it has the benefit of also being portable. The other thing, actually, that I want to try is, let me see if I can show this on the overhead. I'm just going to adjust some settings here, including focus. Bear with me. This is running a Arch Linux desktop on it, and so what's loaded here is their Steam's UI. I think it's called Steam UI. If you hold the power button, you can switch to desktop. Try that again. Why won't it let me? Let me tap it. There we go. Switching to desktop. In this mode, I was able to plug in my CircuitPython device and mount it and open up the code.py. So you can imagine where that's going. We should be able to use this to code in CircuitPython. Since we don't need an IDE, all we need is a notepad. It has Vim installed, and I imagine you can install other editors into it. It probably has NEdit in it, is my guess. I would need to either use the virtual keyboard, which I don't even know how to bring that up in this environment right now. Like I say, I got this like a day ago. Or plug in a keyboard, and then we can use a hub so that we can plug in a keyboard, plug in the CircuitPython device, and then go and code it, which would be really cool to code it right on the device and then pop back over to the game and use it. You might need to do a reset of the CircuitPython device. So very exciting. There's also some, you can get Windows drivers and install Windows 10, I think, on here. I'm not going to do that. I think most people who've done that have said this was not worth the effort. It's not connected to my network. I'm a little far from the Wi-Fi for this to work right now. So pretty cool. And then I think you can switch back to, you can log out of the Linux desktop, and that brings you back, I believe, over to the main game UI, the Steam UI. And off we go. So these, I'm not trying to advertise this thing in particular, other than I'm excited about it, and I think there's a pretty decent waiting list. But you can buy them. You can go to Steam and order them, and then wait quite a while for them to get back in stock. I don't know what their supply chain issues, if any, that they're having are, but people are getting them. They're coming out. They've been getting into people's hands for a few weeks. So, can't wait for Narita Boy. I've been playing that on the Mac, but I'd love to play it on here. I don't know if it works on here. There's stuff that has been certified to work on it, and then there's stuff that they say, maybe, and then there's stuff they say, no, it's definitely not going to work. So that's one I've got to try as well. So anyway, that's enough with that, but I'm really excited to dive into gamepad. So that'll be fun. Any other thoughts? Otherwise, we're going to get out of here, and thank you again for stopping by. I think that's it, right? That's all I got today. Thanks everyone for jumping in. Thanks for hopping into the chat. Nice to see you all. And that is going to do it for this St. Patrick's Day edition 2022 of John Park's Workshop. Stop by tomorrow for a deep dive with Foamy Guy. Is that right, Foamy Guy? I think you're going to be there. If we head over to the Discord, you can probably ask Foamy Guy. You can typically do a show times to see what time the shows are. Foamy Guy's CircuitPython stream is at 11 Eastern on Saturdays. Okay. And then Deep Dive with Foamy Guy, which is taking place at Scott's, is 5 o'clock on Fridays. So there's a huge amount of Foamy Guy. Are you doing both of those? That would be awesome. You can also check, by the way, in our live broadcast announce channel, and that'll show you when streams actually go live. Despite our best intentions of keeping to that schedule, that one is not real time. 2 o'clock Pacific tomorrow, Deep Dive with Foamy Guy. Excellent. I think that's going to do it. Thanks, everyone. I'm going to get out of here and go play some Cuphead. Bye.